Wird gestartet. Transkript.
So, thank you, Martin, for this opportunity to present this small presentation on the integration of life cycle costing into life cycle assessment. It is the topic of my master thesis, and I have done a little bit of research on this, and I think it's very interesting and that I can share this with you. So yeah, let's begin. For the betterment of this presentation, I have divided the presentation into 5 parts. I'll start by explaining some basics, give some introduction, and tell you what the objectives or what are the reasons why the study was conducted and what is the reason that there should be further research on this. I'll give you some overview on the existing concepts, some important points, and what one should know before doing research, and give a basically overview. Then we look at some of the existing methods of integrating life cycle costing into life cycle assessment. We'll look at the specific case study of lithium-ion batteries, and then we'll see what the future holds, basically. So yeah, this entire concept about integrating life cycle costing into life cycle assessment comes from the need to have a common single study which inculcates economic and environmental emissions. And the entire reason this was done was because there is, as you know, there is a dearth of resources. Decision makers need to make decisions which are much more suitable, which are much more agile, which are much more quick, and they need a framework which can help them understand both of these emissions and costs in a single answer. And for that, life cycle costing and life cycle assessment integration plays so much significance. The other reason is that because there is a huge amount of research gap existing in this field currently, and yeah, and there is a huge amount of research gap existing, and that is one way also that we can fill this research gap. We can look at some of the existing methods, some of what are the challenges in integrating them, and we can look at what were the parameters and what are some of the limitations that are considered. So let's begin by explaining some of the basic concepts in this presentation. So we'll start by life cycle assessment. So life cycle assessment is, in short, a method in which all the emissions during a product's life are inculcated. So starting from its extraction to its raw material processing, to its manufacturing, to its usage, and to its end of life. It has been around since almost 50 years now, and around 30 years ago, it was standardized using ISO 14040 and ISO 14044 methods. And they are applied from everywhere from product design to policy making to EPD studies and almost everywhere across the globe right now, specifically in the EU and the US. They are mandated by EU regulations. So there exists an ISO method of doing a life cycle assessment, which has 4 steps. So the first step is by goal and scope definition. So in this step, you basically establish system boundaries. You define a goal. You basically say what do you want to do. Then you tell what is the scope. So whether it is from cradle to gate, which is from your extraction of raw materials to its manufacturing when it leaves the factory, or maybe it's cradle to cradle. So when it is extracted as a raw material and till its end of life, including its disposal. And they change upon the decision maker or the person who's conducting the study. So they're never constant. They can always change. The person who does this LCA study can always change the goal and the scope. And in this step, basically, we also define the functional unit. So the functional unit is basically a common unit by way of which we can measure our environmental impacts. So a very common functional unit is by carbon dioxide equivalent. So whatever the effects of a product or the environmental emissions of a process are, we can measure them in terms of carbon dioxide emissions. The next step is life cycle inventory. So in this step, we basically take all the inputs and outputs of the process or the products that we're going to consider in our upstream and downstream emissions. So all the processes that we defined or are within our system boundaries, as you can see defined here by the green boundary. So in this step, we basically take out the data using our LCI databases. They are available from various companies. They are available in Gabi. They are available by EcoInvent, by OpenLCA, And some companies have their own LCI databases, which includes their emissions of various products and various processes in different stages of their life cycle. And in this stage, basically, we take all the data and we make it together. The next step is life cycle impact assessment. So in this step, we basically take all the data that we had collected in life cycle inventory. We define some impact categories. These impact categories can be emissions to land, emissions to air, to water, can be eutrophication, acidification, human impacts, can be a wide range of impact categories. And then we take some indicators which help us calculate those categories. So these indicators can be global warming potential, can be carbon dioxide emissions, and different indicators. So what we do is basically take the data, we calculate we use the indicators, we calculate the emissions of these categories, and then we define them all using these categories. We move on to the last stage, which is the interpretation stage. So in the interpretation stage, we take all the three steps that we had done previously. We look back at what we had defined as the goal, the scope, the system boundaries, the function limits. We see the data that we collected. We see what the impact of that data was, how much, which process or which was the hotspots in that entire process. And then we interpret and then we recommend changes or some consultancies about what can be done to make the process better. LCAs are of five types generally, starting by attributional LCA, which basically is which takes the average of all the data that you have, which it does not take the minimum or the maximum, it takes the average, and it basically focuses on the current system impacts or the direct system impacts. We have the consequential LCA, which basically looks at the changes that that process or that product will make. So it calculates the environmental emissions vis-a-vis the future changes. The third is the social LCA. It focuses on the social and also the economic impacts, and it is kind of like a small part of a normal LCA, but looking at the social and economic impacts as well. Then we have the environmental LCA. It is basically a normal LCA, but focuses much more on the categories that are environmentally focused and lesser than the human focused LCAs. And in the end, we have the life cycle sustainability assessment. So it basically focuses on all the three pillars of sustainability: environmental, social, and economic, and gives a very holistic and a very broad view. Then we move on to our next key concept, which is life cycle costing. So life cycle costing, as I said, with life cycle assessment, it focuses on environmental impacts throughout the life cycle.
Sorry, Chaitanya.
Yeah.
On which site you are? I see page 3. Is it right?
No.
Ah, yeah. Now.
Yeah.
Okay. I see all the time only page 3. Yes.
Okay. I'm not sure how that happened, but
okay.
Yeah.
You are on page 7, yeah?
Yes. Yes.
Okay.
Okay. So as I was saying, then we have our next key concept, which is life cycle costing. So life cycle costing basically takes out all the costs associated in the life cycle of product, starting from its extraction to its usage to its end of life, same as life cycle assessment, but it focuses on the cost. Now, the key difference between life cycle costing and life cycle assessment is that there is no ISO standard for life cycle assessment, because it varies so much from industry to industry and from sector to sector that it is almost impossible to standardize it using an ISO standard. There are three types of life cycle costing. Conventional life cycle costing, which focuses just on the internal costs, so the costs that are within the system boundaries. Then there is the environmental life cycle costing, which focuses on costs and a little bit of environmental emissions as well, but does not combine them. And then we have the societal life cycle costing, which looks at the societal cost and the cost to society, and yeah, again, does not inculcate them, but looks at them separately. These are some of the most commonly used methods in LCC. So some might be net present value method, payback period, total annualized equivalent cost, global cost, saving investment ratio, and because they vary so much, and because they they are so different in nature and very complex, it is extremely difficult for them to be standardized, because some calculators use internal costs, some include external cost, and because they change so much, it is almost very difficult for them to be standardized. Yeah. Now we move on some of the existing methods that are there or that have been published and verified in our literature. So they start by an independent life cycle assessment and life cycle costing integration. So basically, environmental study and a cost study is done separately, and then the results are basically looked at together. Both of these studies are not done together; they are just done separately, and we just look at two separate results. The next is an overarching framework with a life cycle costing and life cycle assessment. So in this, there exists a framework, but life cycle assessment, life cycle costing happen separately. Then we move on to eco-efficiency. So eco-efficiency is basically you kind of make sure that the product has as little environmental impacts as possible with as less as cost as possible. So it has a very simple formula of dividing costs by environmental impacts, and you can calculate the eco-efficiency. After that, we have mathematical programming. So in this, you basically develop cost models and environmental models using matrices or linear progression models, which you put some constraints on, and then you basically use your objective and you calculate what will be the impacts and the costs. Then you move on to multi-criteria decision analysis, and in this you basically take multiple studies and then you give weightage to those studies, and then you calculate which has the most amount of weightage, and then you decide an alternative based on a number of options. And the last is an environmental life cycle costing. So it is basically based upon using same system boundaries for both the studies, using same functional unit and same scope. Yeah. So what are some of the problems with them? First of all, they're not consistent. They change from person to person who's conducting the study. They change from sector to sector and industries to industries. They're very complex, and it takes a lot of time, effort, and money to do the studies. As I said before, because they are so varied in nature, finding a single one shoe fit all method is very difficult. The third is data availability and quality. So getting reliable data for your costs and for your environmental emissions is really hard. As anyone who has conducted a life cycle assessment and life cycle costing will tell you, that getting companies to reveal their data is extremely difficult, and sometimes the data in the databases is just not reliable. And due to these issues that I mentioned before, there is a acute lack of standardization across the industry. Yeah. Now we move on to the next part of our presentation, which is the lithium-ion batteries. So lithium-ion batteries, as you might have heard about, they work on a simple principle of the discharge of lithium ions from cathode to anode and from anode to cathode. So when you are using a lithium-ion battery, lithium ion moves from anode to cathode, and when you are charging a lithium-ion battery, they move from cathode to anode, and thus the battery charges and discharges, and then we use them. They have been around for 30 to 40 years, and they are an important part of our lives. Our laptops, our cars, our mobile phones, everything have lithium-ion batteries in them, even our smartwatches. They're light, they have a high energy efficiency, they have a long cycle life, and they have become the go-to energy storage system in the 21st century. So lithium-ion batteries have a few stages during their production. So they start by extraction of raw materials and ores. Most of the raw materials come from South America and Africa. Namely, the lithium comes from Bolivia, Congo. Some of the other metals like nickel, manganese come from Africa. So these raw materials are extracted. They're taken for the processing of these raw materials. So basically, lithium is, or nickel and manganese are used to make cathode, anode, other parts. This processing usually happens in countries like China. They are quite big players in this. Then these metals are taken, and then they are more things are added or removed, and then they are made suitable that they can be used to make battery cells. To make battery cells, we need cathode, anode, electrolyte, battery casting, and all the structure that comes with the battery. And that is the fourth step in the battery production, which is the components production. And in the end, all of these are combined together to make a single cell. So these are the 5 major stages during battery production. In the next slide, you can see what are the costs associated with each stage of battery production. So the first stage, which was the mining and the metals, they are about 20% of the total costs. The next stage, which is the raw material production, where these ores are processed, they're about 15%. The third, which is upgrading of these ores into battery grade components, it's about 5%. And the fourth, which is the component production, which is the biggest cost driver in the battery production cycle, which has 35% cost. And in the end, we have the cell production, which is around 25% of the total cost in a battery life cycle. Then we have the emissions. So as we saw the cost, now we will look at the emissions. So the first stage, which is the mining and metals production, it is a very significant cost emissions factor. So it's almost about 25%. The raw material production is less. It's not as high as the extraction of those raw materials. And upgrading those raw materials into battery grade metals is also quite less compared to the other stages. The largest emissions during the battery life cycle is from the component production. As we saw, the costs also are highest during component production, and it is almost 40%. And then the production of the cell, of the battery cell, is also a significant emissions factor, which is just above 20%. All of this brings us to the point where we have now seen what is life cycle costing, life cycle assessment, how they are integrated, the backdrops. And now we have also seen what are lithium-ion batteries, how they are produced, what are the stages, what are the costs at each stage, what are the environmental emissions at each stage. And we can now make a nexus between the two, and we can now look at how each stage of lithium-ion battery, we can maybe look at driving down the costs, we can look at driving down the environmental emissions. And this graph basically shows that how during each stage, what is the optimization potential of costs and emissions. Now, the first stage, which is the raw material stage, there is a very high emissions and environmental impacts potential. So they both have a lot of scope that we can work on, we can focus on energy on, and we can drive down the costs in raw material, whether it is extraction them, processing them, and the environmental emissions. Then another significant, or the next stage, which is the manufacturing one, it is less than the raw material one, but it is still significant, in which environmental emissions are lesser than the costs. And the fourth stage, as we see, the third stage, as we see, which is the usage phase, in which it is being used in our phones, in our cars, in our laptops. In this stage, the environmental impacts are a bit more than the costs, because lithium-ion batteries are extremely cost efficient, and they're extremely energy efficient, and they have a very long life. So the costs are the cost calculation is a bit better than the environmental calculations. Due to the fact that you need to charge them again, and sometimes that electricity for charging comes from a thermal power plant, which is not sustainable, which is not environmentally friendly. And the fourth stage and the final stage, which is the recycling stage, in this, the environmental impact optimization potential is 80%, and the cost optimization potential is 70%. So I think the future energies of all projects should be focused on recycling them, because the current methods that we have for recycling them are just not enough. And that is one area that we need to focus our energies a lot on, because there is a huge optimization potential. Yeah. And then we move on to what kind of opportunities are available for the industry, for industry partners, for companies, and so on. Inculcated study of environmental impacts of costs, basically life cycle costing and life cycle assessment in battery production, can help them in 5 major ways. They can give them a very comprehensive sustainability assessment. They can increase the scope of these studies and inculcate social assessments as well. It will give them a better product. It will give them a better decision making. It will make their product more agile. It will make them more compliant to regulations. It can help them make the entire life cycle more circular and more economically and socially integrated. And the other thing is, they can basically use a lot of real-time data from research institutions, from battery manufacturers, and make their product much more marketable in the 21st century. and they can do this all while complying with regulations that the EU or the FDA or the EPA, anyone sets. Some of the future trends in this combined method are basically improving the current existing life cycle costing and life cycle assessment integration methods. The next big stage would be to integrate the social life cycle, the social part in this. In terms of batteries, we can look at maybe the solid state batteries. We can maybe change the materials that we're using in the manufacturing of these batteries, the minerals, the metals, and so on. We can focus, and we have to focus, as I said before, because recycling has a huge optimization potential. So we need to focus more on end of life strategies. The new regulations that EU publishes or any country publishes, they should be focusing on life cycle and the end of life strategies and recycling of those batteries. We need to make sure that we develop an open, reliable, and trustworthy data systems and databases so that anyone who wants to do these studies and anyone who wants to get real-time data, it is accessible for them. And the other thing is that governments and regulators need to make sure that there is a lot of support available for companies who are either manufacturing them or recycling them. And to conclude everything, we have looked at why it is important to give a comprehensive and a holistic sustainability assessment. We have looked at some of the methods that are already ongoing. We have looked at what those methods, how those methods can help us, and how we can maybe improve those methods. We have looked at how alternative battery chemistries and how adoption of circular economy principles such as recycling, such as end of life and second life applications can help us. And we have also looked at how regulatory influence can help absorb new technologies and develop new technologies and overall help the entire ecosystem being more sustainable. Yeah, this was my presentation. If you have any questions, I'll be more than happy to answer.
Yeah, thank you, Chaitanya. Very interesting presentation about your topic. Und ich würde jetzt sozusagen auf Deutsch wieder umschalten und bedanke mich ja, für die Teilnahme und kann nur darauf verweisen, besuchen Sie unsere Internetseite www.dieserhub.de. Schauen Sie sich dort die Veranstaltungen an, tragen Sie sich ein, nehmen Sie an weiteren Veranstaltungen teil, schauen Sie auch unsere Online-Formate sich mal an. Dort gibt es ganz spannende Themenbeiträge zu ganz verschiedenen Themenschwerpunkten. Und ja, bis zum nächsten Mal.